This is part 4 from my cardiac dysrhythmia interpretation book, and this part begins about page 34. And in this section I want to talk about the graph paper, because in order to be able to interpret ECG rhythms, you have to understand what the graph paper represents. I'm also going to talk very briefly about paper speed with your cardiac monitor. So if we look at the graph paper, first of all, with cardiac rhythm interpretation, so specifically interpreting heart rhythms, not looking at 12-lead ECGs, but heart rhythms. Everything that we analyze is really on in reference to time. So heart rate calculation is a time reference, PR interval is a time reference, QRS duration, QT intervals. All those things are time related, and time is measured on the horizontal plane on the graph paper, as opposed to a 12-lead ECG where we're looking at things on the vertical axis. So for example, ST changes above the baseline, below the baseline. Those are vertical changes. But for rhythm interpretation, we're interested in the time reference in the horizontal plane. So the graph paper is divided into dark 5mm squares, and those are further subdivided into single millimeter squares that we can see here. And each millimeter in terms of time is equal to 0.04 second or 40 milliseconds. So 2 small squares, multiply that 2 would be 0.8 second, 3 would be 0.12 second, 4 millimeters would be 0.16 second exactly, and 5 squares would be 0.2 second. Now I added the 0 here only because 4 multiplied by 5 is 20, so for my mathematically challenged mind, it's just easier to think 0.02 or 0.20 second or 0.20 second. 0.20 second is the same thing as 200 milliseconds. So that's a graph paper. That's the time that they represent. Fairly straightforward. Now, if we look at paper speed, standard paper speed for a cardiac monitor is 25 millimeters per second, and this is not something we have to worry about a whole lot, but if you have a monitor where your battery is getting low or the monitor is malfunctioning, then the paper speed may become altered. And if paper speed becomes altered, then it alters your heart rate calculation, and that's a problem. So the gold standard for calculating heart rate is to take a pulse. Obviously, you know, the patient is more important than the ECG or the monitor, but so we take a pulse, and our objective is to ensure that what we're feeling in the pulse matches the cardiac monitor or the heart rate that we calculate using the ECG monitor. Now, I also mentioned the paper speed because some monitors give you the option of altering or changing the paper speed from 25 to 50 millimeters per second. And you usually see those in monitors in the hospital, the larger heart rate or the larger cardiac monitors rather than the transport monitors. And the benefit or the rationale for having the ability to adjust the paper speed up to 50 millimeters would be, for example, if you had a newborn. Newborns typically have a very fast heart rate, and when the heart rate is very fast, the QRS, T waves, and P waves all become scrunched together, and it may be difficult to clearly disseminate, or not disseminate, but to clearly see the P waves. So if you adjust the paper speed to 50 millimeters per second, it has the effect of basically cutting the heart rate in half, so it spreads everything out, and you can see the P waves, QRS complexes, and T waves more clearly. So most transport monitors don't have that option, but I thought I would just mention that out of interest.